Today's talk is going to be something a little bit different. I'm not going to be focusing on my research, which is probably largely what you hear about at these seminars. If you want to hear about my research, I guess you're just going to have me come talk again. Because this week is, as you heard before, a celebration of the UN International Day of Women and Girls in Science. It's also Black History Month here in the United States, and we find ourselves in the midst of a global pandemic and an ever worsening climate crisis, all of which is demanding our attention at the same time. And this moment that we find ourselves in, I think, really calls for us to do something different than just science as usual. We find ourselves really at quite a nexus. We're grappling with this global pandemic, fighting misinformation on vaccines. There are even debates, believe it or not, about whether or not COVID-19 even exists among some circles. The epidemiologists are encountering the same kind of denialism, but just a different flavor to that which climate scientists have been battling for decades now. It's a time when science and scientists themselves are being doubted. And on top of this, we have the intersection of the racial justice movement. So I thought it's as good a time as ever for us to stop and reflect on how we operate as scientists and question whether we might be better served by taking a more humanistic approach to our work. And so that's kind of the theme of today's talk, as you see here on this slide. And you may be wondering what this image is on this title slide. It is literally the image that popped up in PowerPoint as a design suggestion. I'm not kidding you. But as I looked at it, I decided it was this beautiful visual metaphor for almost anything you could imagine. But it was appropriate for this talk because I think it illustrates how there are multiple pathways to get from point A to B, say from the left to the right side of the slide. You might meet some challenges along the way or opportunities, and it might not be a straight line as you go from one way to the other, but that there are many pathways from getting from point A to B. You could also consider this a meandering stream if you want, whatever you want. This is your own visual metaphor for today, so make of it what you will. Okay. Sorry, I need to move forward. So, all right, since many of you may not know my science, I've allotted a grand total of one slide to give you a very quick summary of what it is that I do in addition to what Ben just told you. So I largely work with fossil corals and submerged speleothems to track the position of sea level through time. So here's a picture of me drilling out in the field on the left, and some fossil corals live near the sea surface, and so we can use them as a proxy for the position of past sea level. So that takes me to tropical islands around the world, which is not such a bad deal as far as things go. But I'm not going to be talking about this research today. Rather, I'm going to be talking about a lot of these challenges that we face today as scientists and in our society. Another big piece of what I do that Ben also mentioned to you is I spend a lot of time doing outreach and science communication, mostly on climate change and sea level rise. This wasn't a particularly, I would say, natural transition for me, or maybe an expected one. When I was very young, I was actually painfully shy as a child. I actually remember this moment in a grocery store when the checkout lady tried to say hello to me, and she commented how shy I was because I refused to answer her because my mom was standing right there, and my mom had told me not ever to talk to strangers. So I didn't. I was terrified of getting my mom upset, so I was very shy as a girl. But then when I graduated from college, I went and taught at a private school in Brooklyn, New York for a couple of years. And I think that teaching experience I taught from age, I don't know, about 10, no, even younger than that, age 8 to 18, across a full spectrum. I taught science at all different levels. And it was really good practice for me in terms of finding my voice, but also being able to speak to people at different levels and figure out how to pitch or change things quickly. And I think that really has benefited me as I've moved into this realm of science communication, which is now a very large part of what I do. It's not necessarily part of my job description, But it's something I feel compelled to do because of the implications of the research that I do that indicate that as we warm our world, sea level is going to rise a lot and very quickly. And there's a real need to share that message. But my approach to this is not to show a lot of graphs and numbers and overwhelm people with a lot of science. If you can see in this image on the left-hand side from my TEDx talk, they put a quote on the top of this photo that was used as an advertisement, which was something that I mentioned in my talk, was that I'm not here giving this talk to save the planet, because as a geologist, I know the planet is going to survive anthropogenic climate change. I'm not worried about the planet. It might be a different place, okay? What I'm really worried about is what's going to happen to human beings. So I'm not here to save the planet. I'm here to save human lives. And that is really the importance of doing this work, is helping people to connect the dots on how climate change will affect them and their loved ones and their communities. Which is why when I do this communication, instead of showing a lot of graphs and numbers, I often show people. So a lot of times you see images of sea level rise with all these cities and buildings been inundated in water as the sea level is rising. But it looks like a movie scene or something that you can't really connect to. You can connect to it when you see people literally standing in the water. And what you're looking at in this image are different people, and it says at the bottom of each of these pictures, when they reach their life expectancy, how high sea level will be at the place where they live. So Lauren on the right-hand side reaches her life expectancy in the year 2078. Sea level in Miami Beach, Florida will be 36 inches. It's about 3 feet, almost a meter higher than today. And all of a sudden you realize, this is going to be a problem. We're really going to have to do something about it if it's going to look like that, right? It's about connecting to people as humans. This is another one of my favorite images. It was a sculpture that was on display in Germany, and it's supposed to be a sculpture of a bunch of politicians standing around arguing about climate change as the water is literally rising above their ears, right? There's a bit of humor involved here because surely this would never get to this point and happen, right? But then this did happen in, I think November, it says here, of 2019, in the region of Venice, Italy. This building, the Italian council, was flooded immediately after they rejected measures on climate change. You really can't make this stuff up, right? So seeing these images as sea level rises, I think really brings the point home about the importance of this issue is how are we going to be able to deal with this change? It's not about saving the planet or saving about planet Earth. It's about saving human lives. So at this point, I'm doing my research, I'm doing all of my outreach. I feel like I'm kind of hitting my stride. And then this thing happened that Ben mentioned to you, right? I got this MacArthur grant. And I think at this moment, it really kind of stopped me in my tracks. Not sure if that's what it's meant to do, but it did. It stopped me in my tracks for a couple reasons. One is it kind of allowed me to have this opportunity to stop and think, what do I want my long-term contribution to really be? This is an opportunity. I can shift gears. I can kind of have my choice of what I want to do and focus on here. I have free reign to make a difference. And so when people interviewed me about what am I going to do with all this money, one of my answers was, well, I'd like to use part of it to help elevate other people, other women in science and other minoritized groups, because it's been an awfully hard slog for me as a woman in science. And it made me reflect on, how did I get here and get this award, which is very rare to get. I work with brilliant people all the time, and a lot of them haven't gotten it, but yet I did. And it made me really stop and think about how this process might work. Now, this process of getting this is a very secretive process. I don't really know. But when people ask me for advice, early career researchers come to me and say, what is your secret for success? I usually boil it down to just one word, and it's resilience. That's what's gotten me as far as I have, is resilience. But today, I'll make it a bit broader than that. Instead of one word, I've come up with three, and I've made it alliterative, all P's. So instead of resilience, I'm going to use the word perseverance. I'm not sure that that's necessarily a good thing. I mean, is it good that in science we're selecting for only the most resilient among us? Only those that can withstand all of the sexism that we encounter along our way on this journey in this career? I'm not sure it is. So that's the first one. Second P, how did I get here? It's decidedly privilege. I grew up in a wealthy suburb of New York City, if you will. I had access to some of the best public schools. I went to a top flight university, which my parents could afford because they'd been saving for it from since I think before I was born. Education was a priority for them. So there's no question that I was very privileged in that sense. I grew up being told that I could be anything I wanted to be. And I took that to heart and I went and I guess I went and did my thing. And it made me feel, in reflecting about this, a bit uncomfortable about getting this award. Maybe I got this because I am privileged, and that's wrong. It shouldn't be like that. But the third P in this story is an important one too, and it's my parents. And I know everyone could say, oh, my parents have supported me and that's how I got here. But really, my parents are extremely dedicated as far as parents go. I got divorced shortly after I started my tenure track position when I was at the University of Florida. My kids, 2 kids, were very young. I was convinced it was going to be nearly impossible for me to even get tenure, to publish enough, or to go do my field work. How was it going to be possible as a single mother? I didn't know any other single moms who got tenure. I couldn't think of one. I asked around, I asked all my friends, no one could think of anyone. There's a reason for that. You need a support network to get there. And my parents really stepped up and they became my support network and made it possible. So I literally, everything I have achieved from that point, I chalk up to them because I would not have gotten here without them. So it was perseverance, privilege, and parents. Okay, so let's fast forward 6 months from the point I got this award. I went off to New Zealand for this Fulbright scholarship that Ben mentioned. And of course, the pandemic came along. Now, I just happened by pure luck, as it would be, to be in New Zealand when this hit, which was probably the best place to be in the entire world. We went into a lockdown as coronavirus cases surged around the world. I was working at this time on this report that I'm going to talk about in a few minutes for the National Academies that Ben mentioned. And then in the end of May, as all of you know, we had this incident with George Floyd where he was killed because he could not breathe. And I can't breathe became really the phrase of 2020. And it had multiple meanings, but of course, in this case with George Floyd, it was quite profound. And my voice gets shaky because I still, this whole movement, this racial justice movement has been a real reckoning, and it's been due to come for a very long time. And it changed my perspective in the past year as I've kind of thought about this and dealt with this, about what I'm going to do in the future and how I am going to hopefully leave my legacy in science. And it needs to be broader than just women in science. I was biased myself because I was focused on women and the challenges that they have in science. And I've persevered through a patriarchal academic culture that selects for only the most resilient among us, not the best and the brightest or the most innovative and the most creative, but the most resilient. We're the ones who survive. And while I have experienced plenty of sexism, one thing I never had to deal with was racism on top of that. So when I look around me now, within my profession, I see an overwhelmingly white demographic. And there's no question in my mind that my career has benefited from that white privilege. And I look around not just within earth sciences, but around in my life and the places where I work and live. And I realize that the status quo really needs to change. And perhaps more eloquently, put in the words of Amanda Gorman, who gave a stunning recitation of a poem at the inauguration of Joe Biden, for those of you who saw this, she said that what just isn't always justice. And this has really changed my perspective and my outlook quite a bit. So my roadmap for the talk today, again, is really centering on our roles here, not just as scientists, but as humans. And I tried to make a Venn diagram of the topics I'm talking about tonight. A few light topics here you see on this image. Not sure it's the best Venn diagram, but the idea I'm trying to get across is that there's an intersection here in the middle about a pathway for dealing with all of these things that requires a more humanistic approach and treating others with respect and dignity that they deserve. So what I'm going to do now is I'm going to go on maybe a slight bit of a tangent, but I'm going to talk a little bit about this report that we produced for the Earth Sciences Division, the National Science Foundation. That's this outlook of research questions for the next decade. And I'm going to tie it back in to all of these things with this common thing about the importance, the roles of people in solving some of the problems that we face. Okay. So this next set of slides I'm going to show you are part of the actual official briefing slides that we used when we rolled this report out last year. I think it was around May or June that it was finally published. It's available online as a PDF. If you want to go search under the National Academy's Earth and Time, you can find this online and download it. It's a book. If you want a book, if you prefer paper copies, you can go get yourself a book or ask your library to order it. And if you want kind of a high-level overview of the report, there's a webinar that we gave. It's about an hour long, and there's a link to it when you go search it on their website if you want to watch that. I'm going to give you a briefer version of that webinar now to highlight a few things for you. And the icons that you see underneath this title are meant to represent the themes of these 12 research questions that we laid out as priorities for research in earth sciences over the next decade. So first, to back up a little bit, I want to explain to you, for those of you who are not familiar with the National Science Foundation in the United States, a little bit how this report worked and how this organization actually works. So within NSF, there's something called the Directorate of Geosciences up here, and underneath that, there are these different divisions: Earth Sciences, Ocean Sciences, Atmospheric and Space Sciences, and Office of Polar Programs. So this report was basically commissioned by the Earth Sciences Division of NSF. And what they have beneath them a much more disciplinary programs, more focused research programs. And they gave us a three-pronged statement of task. So this is what they asked us to write about. We couldn't write about whatever we wanted to write about. We specifically were tasked with addressing these points that they wanted feedback from the community, so that as they move forward over the next decade to shape programs, they can point back to this document and say, look, this is what the community said we need to do. This is now what we're going to tackle as an organization. So the first task they set for us was to come up with a concise set of high priority scientific questions. The second part of the task was to identify the infrastructure that we would need to achieve reaching, the answers to all of those questions. That involves looking at the current inventory of research infrastructure that we have, analyzing those capability gaps so that we can align the infrastructure with the research questions in point one. They also asked for a discussion of how the Earth Sciences Division can leverage partnerships within other federal agencies, for example, and other organizations, and to run this additional workshop on geophysical facilities management models. I'm not going to talk much about what's on this slide. For purposes of today, I'm going to focus mostly on those first 2 points. So I'm going to start off with a little bit of the vision of the report, show you some of the science priority questions, and then talk about the infrastructure and initiatives. So Earth Sciences can further its mission to support basic science by considering Earth as an integrated system whose components interact on vast scales, time and space, from milliseconds to billions of years, and from nanometers to thousands of kilometers. Now, this is not a new idea, but it was one that was highlighted in the feedback that we got from the community. And I should say this report, I should have explained this earlier, is a consensus report. It's meant to represent the consensus from the community. It's not the opinions of the people who were asked to serve on the committee and write the report, such as myself. It reflects the feedback that we got from the community. And we had a statement in there that this is really an all hands on deck moment for earth sciences, and that has multiple meanings. It reflects the need to integrate across subdisciplines, but it also reflects the societal relevance of many of the priority questions that make this research extremely relevant and also urgent. But we also noted that realizing this vision will depend on scientists who are intellectually and demographically diverse, who are individual investigators, as well as those participating in larger groups and teams and networks, and who have expertise in analytical, computational, and field-based methods. So for the approach to this, we had a lot of different means of gathering feedback from the community. A lot of those are listed here. I'm not going to read through those now. But from all of this information that we gathered, the committee honed in on a small set of priority questions that are both of fundamental importance to earth science and poised for progress and transformative impact in the coming decade, right? So that was key. So many of these priority questions reflect Earth as an integrated system, as I mentioned before, but they also reflect technological advances that will enable new observations and computational models, and they reflect the societal relevance of basic research. Progress on those priority questions will depend on still having strong core programs in earth sciences and on research agendas driven by individual investigators and groups. But we emphasize that the priority questions are not meant to exclude other areas of research. Basic research will always have the potential to lead to unanticipated and transformative results. So these are the 12 science priority questions. You can read through some of these. Probably most of the earth scientists in the audience can find themselves in one of these questions somewhere. We wrote kind of several pages for each of them to go into more depth on those. I'm not going to go into a great deal of detail on a lot of these today, other than to highlight a few kind of overarching themes. The questions are arranged here on this slide, roughly in order from Earth's core to the clouds, and they embrace several themes. The questions span geologic time. They highlight connections between the Earth's interior and the Earth's surface, and the coevolution of geology and life, and the effects of human activities. The questions themselves connect to each other, highlighting the many unexpected ways in which different components of the Earth system connect and interact. And in the interest of time, I'm not going to give an overview of each question, as I mentioned, but I'll encourage you to view either the online webinar if you want to learn more, or to go to the report itself to learn more about each of these research priorities. I think I did keep in one slide from one of the questions that I thought maybe you might have a special interest in based on your location, but also I put this one in because I think it was one of my favorite questions. And that was one of the fun things about serving on this committee, was getting to listen to all these different diverse disciplines and what was really cutting edge in all of these different areas. But one of the reasons this question was one of my favorites is because it's a deceptively simple question, and it might strike you as a bit odd. Why are we asking what is an earthquake when you can find that answer in any introductory level textbook? Earthquakes are, as you know, sudden onset geohazards that pose a profound and ongoing threat to lives and property. They're understood to occur in sudden motions of the Earth caused by rapid slip on planar faults. However, recent observations have revealed that earthquake rupture is geometrically and dynamically complex at all scales, and that Earth deforms through what we might think of as ordinary earthquakes, through slow earthquakes, and through diverse mechanisms that are completely aseismic. This deformation occurs over a broad range of temporal scales, from seconds associated with rapid slip to millions of years for plate tectonics. So the diversity of deformation styles has caused geoscientists to actually reconsider the very nature of earthquakes and their dynamics, and led the committee to pose this deceptively simple question that we are now prepared to address in full. What is an earthquake? All right, so that gives you a little hint at some of these questions. And so if you're intrigued to learn more on some of the others, I encourage you to go to the report and to learn about them. So now turning to the second task that we had in front of us, this one was based on infrastructure. And so we looked at the facilities and infrastructure that are supported by Earth Sciences at NSF. And this really makes up the bulk of the budget that they have. There is a lot that they support. And most of that is really instrumentation, and some of it is cyber infrastructure. And we looked at both of those in great detail. But we also had another section on humans, and we talked about human infrastructure. So by human infrastructure, we refer to the people who design, build, maintain, operate, and continually improve these hardware and software tools. But we also refer to just the human workforce in Earth Sciences as well. So this was kind of a new approach in describing people as an essential component of infrastructure, and it reflects our view that the future Earth scientists will need new skills to develop the next generation of instruments and to access and utilize the available information in new ways. So in our view, Earth Sciences has an opportunity here during the coming decade to be creative and intentional in developing this expertise such that we build an increasingly instrument-savvy, cyber-capable, and more diverse and inclusive workforce. So there were a number of infrastructure recommendations that came out of this report, and I'm going to gloss over these now. I've put them up here for those of you who might be interested in some of these initiatives or learning more about them. I'm just going to scroll through these couple of slides on here. And again, this was all based on community feedback we hear and how well organized some of these communities are and whether they were ready to kind of act and develop these different programs. Okay, but what I want to get to, because this is kind of the theme of today's talk, is to talk a little bit more about the human infrastructure recommendations. So this is an issue that is absolutely fundamental to the success in implementing the vision that's put forth in this report. Yet it poses some challenges in developing and sustaining sufficient capacity, expertise, and diversity. Preparing the next generation of earth scientists for an increasingly technological field will be enhanced by strengthening the financial support for technical staff in a way that is competitive with other opportunities that they may have. To that end, Earth Sciences should commit to long-term funding that develops and sustains technical staff capacity, stability, and competitiveness. And that was the recommendation that we made in the report. Finally, if we are to make true progress in the area of diversity, equity, and inclusion, then we really must elevate this as a priority in Earth Science community. EAR, the Earth Sciences Division, has already responded to this issue through multiple initiatives, yet Earth Science remains one of the least diverse STEM fields with respect to underrepresented minorities, and gender diversity drops off significantly with increasing career rank. In short, the representation and inclusion of diversity in our discipline continues to impede scientific progress in education. Hence, the recommendation here is that EAR should enhance its existing efforts to provide leadership, investment, and centralized guidance to improve diversity, equity, and inclusion in the earth sciences community. Right, so clearly the fact that this appeared in the report at all means that it was strong feedback from the community. Again, this is a community consensus report, not just the opinions of the people who wrote the report on behalf of the national academies. And so this was based on the strong feedback that we heard from all earth scientists. All right, so final thoughts. These are kind of final thoughts from the committee. Then I'll move to my own personal final thoughts. These are some final thoughts that reflect some of the key points of the entire report. So the Earth Science Division's mission is really more important and urgent than ever. And this report describes that in detail and with examples and ideas. Second, the 12 science questions illustrate the significance, breadth, the magnitude of the challenge and the opportunities for earth science research in the next decade. Although these are, of course, just some of the research questions that are poised for significant advance in the next decade. Third, implementing the cyber and human infrastructure recommendations in particular are going to require a commitment of funding and significant changes in the earth science community, which needs to be more diverse and inclusive and to be trained with the key skills necessary to advance research. Finally, EAR already leads investigation of Earth as an interconnected system, and it is poised to launch the next decade of innovative research. So this report highlights the urgency, the significance, the impact of research, the education and training supported by EAR, and it concluded with optimism for what earth science researchers have accomplished and what we can do in the next decade. Okay, that's kind of the official briefing slides from the report. I've selected the highlights in part that I wanted to focus on today. My own personal reflections, though, are this piece about education and outreach that were mentioned but not really focused on in the report, because to be honest, it was really a bit beyond the statement of task that was before us. But this is a really important piece because in my mind, we can do all this wonderful, great research that has incredible societal significance, but unless we're able to convey to people its importance and how it will impact their lives and how it can help us to shape effective policies, then it's really not very useful at all. So we really need to be doing a much better job at education outreach. And part of the reason I say much better is it's quite clear that right now we are failing at that, right? So take the flat earther movement as an example. You know, I went looking for pictures of this today. I don't think about the flat earth thing a lot, to be honest. But with all these artist renderings of it, it made me kind of wonder, what did the flat earthers think is underneath on the other side? And why haven't we explored that? And it's really just kind of a fascinating concept. But sorry, I digress again. Flat earth, like how could that be a thing that people really believe in this, that this is true, right? Or let's take climate change, right? Climate change is not a hoax. Again, many people are convinced it is, despite seeing the evidence, as you can see in this cartoon, right before their eyes. It is now playing out across our TV screens or our news feeds or however it is that you get your news. Now with the pandemic, right? This image of someone with a mask over their eyes pretending that COVID-19 doesn't even exist, perhaps not entirely accurate because these people wouldn't even have a mask in the first place, but nonetheless, still you get the point. We're failing here as scientists, or someone is, as in terms of providing this basic education that people can evaluate this information. And we are unable then to communicate the science that we do understand and help to shape that into effective policy. Now, a lot of people say that they think that science shouldn't be politicized. I push back on that phrase a little bit because I think science has an extremely important role in politics and in shaping policies. What it should not be is partisanized. Now, I'm not sure that partisanized is a word. If it's not, I really think it should be because it's very appropriate here. But science should not be a partisan issue, right? But it does have a very important role in politics. So, and we go back to this concept of human infrastructure, because this gets, again, to this point of education and outreach and about fostering our communities and our community within earth science. And that implementing those recommendations we made in that report is going to require something other than business as usual for the community. That we haven't been valuing the people who are doing the work, helping to provide them with funding and stability and career advancement and professional opportunities, especially when it comes to technicians. You know, so we offer now oftentimes professional development for our students and for our postdocs. But what about the technicians? They're kind of lost in the shuffle there, right? There was also this second component about needing to enhance our efforts on DEI. And DEI, this acronym has been changing a little bit, diversity, equity, and inclusion, especially over the past year. There's one acronym I quite like, which is Justice, Equity, Diversity, and Inclusion, because it's Jedi, the Star Wars theme. But it also brings in this justice theme. There are larger acronyms that are out there now. I'm not sure that the larger ones are going to hold, but I quite like this JEDI one. So why am I talking to you so much about humans and diversity today in this talk? One, because I think you need to hear it. I think everyone needs to hear it. But two, because the unfair treatment of minoritized groups is not an issue that is isolated to the United States. I recognize that you have the privilege on a Zoom meeting of stopping this video and not watching it right now if you don't want to hear me talk about this. And you may be able to choose when you want to listen to or pay attention to diversity, equity, and inclusion, but not everyone can, because for some of us, these are issues that we grapple with every day. So this issue is really no longer a sideshow, and it deserves a spotlight here in the community. And so I'm here to do my part to help shine a spotlight on this issue, because the geosciences have a whiteness problem. I think this image really gets that across. I don't really pretend to be an expert on such matters, but I acknowledge my privilege as a white woman, and I have chosen this moment to listen and learn and lift up the voices of others. And it's my intention to continue to use my position to take actions to break down the systemic barriers within our discipline that have created, quite honestly, a stifling and toxic atmosphere for many talented and innovative and brilliant scientific minds. Because when we build up people, we build up science. You really can't separate the two. But my words to you today are not just for the sake of science alone. In fact, they're more driven by my belief in fundamental human rights, and that a reckoning of racial injustice is far overdue in a general sense, but especially within the sphere of academia, and more specifically within the geosciences. So for those of you who are not familiar with the lay of the land here, I'm going to share with you some rather breathtaking statistics. And I realize that these are from the United States, but again, this is not an issue that is isolated to the United States. And these data are obviously the ones that I'm most familiar with, but this pertains to the broader international community as well. So what you're looking at here are the percentage of master's degrees awarded to underrepresented minorities, as defined by this asterisk and spelled out in the bottom left-hand corner in the United States. And you can look at the trend from about 2006 to 2016 over that decade of time. And you see there's not a lot of change for the most part. And also that earth sciences is dead last among the STEM disciplines, right? Hovering somewhere between 5 and 10%, in no way reflecting the general population, of course, either. So it's a problem within STEM. It is a much bigger problem within earth sciences. And I think it's really striking when you see these data. So for those of you who have not read this article here by Kuheli Dutt, I strongly recommend that you do. It's a very short 2-page article. It's worth every moment of your time. And she also just published another short piece, I think in Nature a few days ago, that's also worth reading. But one of the things that she discusses is the need for a cultural change within our discipline. She says the only way that we can change the geoscience culture is by a massive shift in individual mindsets with the aim of moving the field from passively non-racist to actively anti-racist. It's no longer enough to be silent and say that you're not racist. We need to all be actively anti-racist, is the argument that she makes here. And then I am lifting up her voice and saying that as well. So one of the things I recommended, I gave several of these slides that you've seen now at a plenary talk at a large international conference last summer. And one of the things I offered up to the audience at that point in time was the following, something that we could all do immediately, either if we were leaders within our departments or divisions, or by talking to our leaders, is in our annual activity reports to describe the steps that we have taken in the past year to improve the diversity and inclusion of our research groups, department, and or the college and university. And even if you've done nothing, it's not necessarily something you're evaluated on, but it forces you to reflect and list down what have you actually done? Because we're not going to make progress unless we're actually out there making progress, making policies, changing things, doing something other than the status quo. Again, being actively anti-racist. So I found this meme online. I think it's quite good. It applies either to COVID-19, and you can read through each of the points, and it makes perfect sense in that context. Or you can think about it in the context of the Black Lives Matter movement and think about racism and treating racism like COVID-19. People don't like to think that they're racist, but we exist in a society that has institutionalized this racism. And by being part of that, we inherently are racist by supporting those institutions and letting them continue. And so I think this is a really good set of things to live by, both with respect to both of these things. So if we come back to my poor Venn diagram that we made before, I think we can really move this issue of racism to the center because there's an intersectionality here. It overlaps with all of these things. And I don't think we're really going to be able to make true progress in any of these areas unless we can tackle racism and racial justice. So what does this mean for the future of our sciences in particular? We need to move forward by thinking of diversity as more than just gender equity, right? So the geoscience profession has long recognized that it has a pretty homogeneous composition of white men when you look at it on the whole. And in the past several decades, there's been a push to really improve these demographics by focusing on gender parity. But we need to think of diversity as more than that, and especially so within the context of the racial justice protests that have gripped the world this year. One could argue that diversity efforts, in fact, that have centered upon increasing the representation of women in geoscience have potentially done so at the expense of other minoritized groups. So what can you do? There's a whole lot of things you can do, but I think the thing is that you need to treat these as more than just a list of things, but by investing in it in kind of every aspect of what you do. So I'll give you some examples just to illustrate. Oh yes, I forgot about this comes first. Before I get to those examples, is that instead of thinking about minoritized groups as being the minority, and it makes it sound like the problem is somehow on them, that they're the minority. I really like to think of this as flipping it around and thinking, instead of thinking of them as underrepresented, think that our discipline is actually overrepresented by white researchers, which I think is a good way to look at it. Okay, so to the list. What can we do? In addition to diversifying our student body and our faculty, the real key part is inclusion, and not just diversifying, but making everyone feel welcome and allowing them to succeed in that environment. So how can we do that? We can connect people with affinity groups on and off campus. We can identify mentors with similar social identities and those with different social identities, those from the majority group. They will give different advice, I'm sure of it. We can ensure that minoritized individuals are not overcommitted. That is not a typo, not overcommitted, overcommitted. So as a woman, I know that oftentimes they're always looking for a woman to serve on every committee, so they have some representation, but this can become a real burden if those who are underrepresented are doing all of that work to represent. We need to all be allies. We can provide financial support for professional development. We can include everyone in social gatherings and not make them feel marginalized. We can designate facilitators for all department committees, making sure that all those people on the committee make sure that everyone's voice gets heard. We can enact policies to remove barriers to success. You know, someone said something recently to me is that how we mentor people is often teaching them how to navigate the barriers that exist and how to get around them to succeed. But maybe instead of doing that, we should be talking about how should we be taking down those barriers to enable those people to succeed, which is a whole nother way of mentoring people. So I've focused a lot today on this issue of racism and racial justice, but if we circle back to the theme of this week, this International Day of Women and Girls in Science, I wanted to highlight this film that maybe some of you have seen, and if not, I really highly recommend you get yourself to an online screening. They happen fairly often. You just have to look around for them. It's called Picture a Scientist. It highlights 3 different women, one of whom is an earth scientist, Jane Willenbrang. We've made a lot of progress in terms of women in academia and in earth science, but in earth sciences, we are still decidedly a minority, and especially so with increasing career rank. And there is still a lot of work to be done. This movie was actually quite hard for me to watch because it brings up a lot of things that I went through as well in my career. And the way I was mentored is that I was really told to kind of lean in, is to adapt to the system, as I was just talking about. So I made myself fit in. I played by the rules such as they were, but now my game is starting to change. And instead of playing by the rules, I'm ready to help change those rules and break down barriers to help others succeed. And sometimes the stories we hear about how perhaps women in STEM get treated are the most egregious stories, right? The ones that are like very obvious that something was done wrong. But what is also an equally large problem are things like microaggressions that people think, well, why does that bother you? It's just a small thing. There's a quote in this movie that I wrote down on a Post-it note that's still sitting on my desk that I found somehow extremely profound, which is that a ton of feathers still weighs a ton. It's, I suppose, a scientific way of looking at it. Maybe it wasn't just one really bad act or really bad actor, lots of little things, but it all adds up to a ton that you still carry with you, and you have to carry if you want to succeed. So perhaps the 3 most important words of this entire talk might be the problem, or might be the problem, might be the most important words. Be an ally. That is my best advice to all of you. The burden on making this cultural shift should not rest just on those who are minoritized. We need allies at all levels, all career levels, and all different types of people. Find a way to be an ally. So I'm winding up here. I hope that this presentation gives you a pause for some further self-reflection on how you can become part of that change and part of that cultural shift. And I'm ending with this cartoon, which came out sometime last year, which I think really hits the nail on the head. We talk about flattening the curve of the pandemic, yet we're in the midst of this looming climate crisis, which could potentially be a whole lot even worse than that. But as I've argued today, I don't think we'll really be able to effectively tackle either of these until we start building better communities amongst us and we start tackling the issues of racial justice. Because as long as we continue supporting the status quo, if we as scientists continue just focusing on science in our seminars and our plenary talks, if we continue to select for the most privileged and the most resilient, then we're not going to change things. And fundamentally, we do need to change. So while there may be a lot of things that maybe we don't have in common with each other, I think the pandemic has taught us that, like it or not, we all share a common future, and that our individual actions, not just with respect to COVID-19, but with respect to the climate crisis and the racial justice movement, are going to impact all of us. And as always, the cost of inaction is far greater than the cost of action. So silence is no longer our friend anymore. We need to be active and not passive. We need to all find our own voices as scientists and not be afraid to show our human side, to be humans and treat others as humans to meet the challenges before us. So I'm going to leave you today with this quote again from Amanda Gorman. We've learned that quiet is not always peace, and the norms and notions of what just is isn't always justice. Thank you.